Hello, hello. Good morning. Good morning out there. Good morning. There's two of you out there. Good morning. Hope everyone had a nice weekend. It was a beautiful weekend, right? It was nice. It was like 70-ish. And it looks like it's going to be equally as nice today, but I don't think it's hot. But welcome, welcome. Hope everyone, again, had a great weekend. For those who are just joining us, um, is there anybody out there? I think there is. Hey, Sarah, good morning. How are you? I hope you had a nice weekend. I'm actually kind of tired today. I don't know what it is. So we'll have to test the whiteboard. So let's see. Let's figure out what I should write. We know what tomorrow is. So tomorrow, Taco Tuesday is going to be like extraordinary. Like what a perfect day. Let's see. So what should I write on the board? Why not? I mentioned this character quite often. We are live on the board, so if you can please write what you see, so this way we can confirm whether this is working. Good morning, Leanna. Welcome to our class. The whiteboard is up and running, so please, if you can just check to make sure that you can read what's there. That's right, Baby Yoda. But I will say this. Good morning, Gianni. But I will say this. I watched maybe like 2 or 3 episodes of The Mandalorian. And for the post, why I mentioned Disney is because I believe Disney now owns the rights to Star Wars or that whole franchise. So, with today being, May the 4th and all that stuff, yeah, figured why not make it fun. Baby Yoda. That's right. There's only 3 of you in here. Then again, it's only 9:01. So I'll give you a few more minutes to settle in. Hopefully, you saw that I graded the exam this weekend. I was able to provide some comments here and there. I actually like using what is it, Google Classroom, and making comments and highlighting so that this way you can actually see the exact area where you made a mistake. I mean, you could do that anyway, right? If you were in a classroom, I collected your work, I would make a note on the paper, so it's not really too much different, but I think it's cool. But it's much more time consuming. Let me tell you. Oh my God, it is. It takes a long time to grade electronically. So welcome, welcome. So we'll start in like a couple of minutes. Wow, only 5 of you. So I guess I can give you the announcement that there will be a final exam. I'll give more details as they become aware, but in the past, when you were in statistics, there was a departmental final exam, and again, that was given in-house. The exam was created by LaGuardia. You took it, I graded it, I would walk all the way to LaGuardia and drop that exam off. So, there's going to be a departmental exam with this class. I don't know how it's going to be administered. I really have no idea. But I know that it's happening, and there's a chance that it could be all online. Again, I was just told that it's happening, that it was created, but I'll have more details as the days go by. But it's happening. I think it's going to be given towards the end of the month, So again, I think there's a chance that we may finish this class early. As I mentioned, I want to say like 2 or 3 weeks ago. So the original date I think was June like 2nd or 3rd that this class was supposed to end. Basically that week of, when would have been your prom. I know that really sucks. It's kind of heartbreaking, like even like me like saying it like for you guys, it sucks. You should have that experience, but it is what it is, and hopefully something will come in the future that will be just as good, if not better. But yeah, this is the reality, unfortunately. But with that being said, I believe that the class will end earlier, probably the last week of May. Again, I'll stand corrected, but that seems to be the way that this is going. So we'll see. Val, does it mean it has to be all the units combined? All right. So we're talking about a final exam, right? Yes, it will be a departmental final exam, just like the statistics exam, right? It was like what, 9 or 10 questions. It was basically like one question per unit. So it's going to be something like this that's similar in nature. I know that when you took the exam in class, there would be roughly 20 questions, all short answer, but the review sheet, which I'll be sharing with you maybe by the end of today, so that you can start looking at the questions and thinking about it. And then as the days go by, or even like the week or so that goes by, I can refine the questions that you have to focus on, so that this way, uh, you know, when you take the final exam, it will be less intimidating. But yeah, it's going to be comprehensive, cumulative. It's going to be all the chapters, everything that we discussed. Okay, so let's see. We should start or get going. I can't really wait too much longer. All right, so let's begin. So we're in chapter 5.2 now. We're looking at trigonometric functions. So if you look at the sections within this chapter, or within this portion of the chapter, we're going to be looking at trigonometric functions, quadrantal angles again, but in more depth, and it's going to play a larger role in what we have to discuss. Some reciprocal identities, signs and ranges of functions and values, Pythagorean identities, and quotient identities. So it's like a lot of identities and proving this and that, but we'll build to it. It's not too intimidating. I mean, right now it may seem that way, but as we move along, you'll find it to be on the easier side. But again, it's kind of like when we were looking at logarithms and deriving some of the properties. It's something along those lines of a derivation. Oh, good morning, Mamadou. Okay. So let's begin. So where are we? All right. So trigonometric functions. So here again, trigonometry applies to a right triangle. So we're going to the board. I'll quickly just go over that. If you have a right triangle, right, and you have some angle x, some angle y, and you have side lengths, let's say A, B, C, you can use trigonometry to find side lengths, right? So that's number one. But number two, when you're on the coordinate plane, the side lengths can be found by the coordinates that are given. So we're typically working with a unit circle, or this idea of a unit circle, again, where the radius is 1. So if we look here, let xy be a point other than the origin, it should be other than the origin, on the terminal side of an angle theta in standard position. Let me write that in here. Sorry, you get to see the edits live. Okay, so let xy be a point other than the origin on the terminal side of an angle theta in standard position. The distance from the point to the origin is expressed as follows. So that should be somewhat familiar to you, in that it's the Pythagorean theorem. So if we're using, so I'm on the board, so if you want me to clarify this, so if you look at it this way, right? R is a radius, so if this is a circle, right? So we can look at it this way. Oh, it's so poor. I'm so sorry. Poorly drawn. But if we had a circle, So here would be the radius. And what we can do is we could find the radius length and imagine that you're on a coordinate plane. So there's a couple of other things that, or caveats to go with this. Right? You're on a coordinate plane, x, y. So this would be some length x, some length y, so that when you try to solve for the radius length, that's going to come from the squaring of x added with the squaring of y, and then that will equal to r squared, which is the same as a squared plus b squared equals c squared. So this formula, Pythagorean theorem, but on the coordinate plane and working with circles. So you can use that to find the length of a radius, but this formula also goes back to the distance formula. So it's all related. It's just in different contexts. So let's see here. You should remember, so if we're using this triangle, I think, yes. So what I want you to do, I want you to think about the trigonometric ratios that we've discussed in the past. So here we have y, x, and r. And if we have theta, so we're going to put theta at the origin. We'll put it here. So with this idea, you should be able to recall what sine theta is, cosine theta, and tan theta. So if we need about 30 or so seconds to recall, I'll give that to you, but start to think about the angle where it's located and then the ratios that correspond to that angle. So when I go over trigonometry, I try to make students think of it as just fancy ratios. That's all it is. Fancy ratios when you are working with a right triangle. And you use the ratio when you have limited information. But at the very least, you need an angle measure, a side length, or two side lengths, perhaps if you're trying to find an angle measure, but some combination. You're not going to have all of the pieces, but typically it's an angle and a side. Because if you had two sides, then you can find a third side. But typically when you use trigonometry, it's when you have the conditions. And what are they? Condition of a right triangle, the condition of having an angle, at least one, and then the acute angle, and then you'll need a side length. So hopefully in looking at these ratios, you came up with the following. So the first three should have been fairly simple to find, right? Sine theta, or if you remember SOHCAHTOA, right? That could also be helpful here. So I'll just write it here. So SOHCAHTOA. But then on the flip side, and literally on the flip side, we have these other functions. So sometimes they're called the reciprocal functions, or co-functions, if you will. So you have sine theta, but just look at the ratio. Look at it. It says y divided by r, or opposite compared to the hypotenuse. Don't forget when you label, right, with respect to the angle, I should make a note of that. So we're looking at the whiteboard. So with respect to the angle, the opposite side is opposite that angle. The hypotenuse is always opposite the right angle. And then the remaining side, we call the adjacent side. So look at the ratio. Opposite to hypotenuse, that's sine, or y divided by r. But if you flip it, it becomes r divided by y. But here, let me just make that clear. So sine theta, if we flip it, 1 divided by sine theta, this takes on a new name. And we call that cosecant theta. So it's just giving a new name or a fancy name to one of the trig functions when you take the reciprocal of it. So cosecant theta is the same as 1 divided by sine theta. So when you're looking at this chart here, 1 divided by r becomes r divided by y. Similarly, when you look at cosine, cosine is adjacent to hypotenuse, or x divided by r. If we go back to the previous image, so we're referencing this, so all of these pieces that have been identified, y, x, and r, these ratios are formed based off of that figure. So again, cosine adjacent to hypotenuse, or x divided by r. But if you flip that, it becomes r divided by x. But when you flip, now I'm going back to the board, but when you take the reciprocal of cosine theta, or 1 divided by cosine theta, we give this a new name. And that name is secant theta. So this is where the vocabulary becomes a little bit complicated. They're very simple things with complicated vocabulary. You've learned reciprocal in middle school, maybe even elementary school. Now these reciprocals have special names. That's all it is. And in this case, this reciprocal is called secant. So what's secant? Instead of adjacent to hypotenuse, it's hypotenuse compared to adjacent, or the flipping of cosine. Similar approach with tan theta. Tan, right? Opposite over adjacent, y divided by x. But you flip that, then it becomes cotangent theta. So this I'll write here. So cotangent, sorry. So here tan theta, it will become 1 divided by tan theta when we do the reciprocal, but that's the same as cotangent theta. Sorry for the sloppy theta symbol. But again, it's just flipping. So here, so we're going to look at example 1. So you should go to your classwork section. So again, if you're just joining us, let's see, there's about 14 of you here. Welcome all 14 students. Everything should be in Chapter 5 learning materials. So find the handout. I hope I have it. I should. I'm just finding the title. Right. So it should say trigonometric functions, the title. So the file name is mat115, trigonometric functions, practice problems. And I believe the first question says something like this. I'll copy. Can I copy? Yeah, I can. I'm going to copy and paste it poorly into here. Let's see if it does it. Yeah. So I just pasted the question so this way that you can look for the actual handout. It'll say something like this. Angle Q. I guess this chat doesn't know how to write theta. So just ignore that. I'm just sending that so that you can see where you need to reference. So take about 30 seconds to find it, and then we'll begin. Good morning, Josh. I need more coffee, so give me like 20 seconds. Alright, so hopefully you found that. It will be very helpful here if you had a separate sheet of paper so that you can draw this out, because I'm going to be drawing it out on the whiteboard. Okay, so I think that's plenty of time. So let's go to that example. I copied and pasted it in the chat so that this way you can reference it if you're looking for it. Again, the title of the PDF is Trigonometric Functions. We're looking at number 1. So it says something like this. The terminal side of angle theta in standard position passes through the point 815. So if we do something like this. So let's see. Just give me 1 second. Okay, so you see the plot will approximate 815. It looks something like this, right? This is very poor, but it's enough for us to work with. So we have this. So we should do the following. So the terminal side, right, of angle Q in standard position passes through, right, to the terminating side, right? So the initial side, right, again, referring back to vocabulary is here. So when the angle goes in this direction, you can form the right triangle. So what happens here? So this length of x, right, here's x, here's y. X is a length of 8, y is a length of 15. And really what we have here now is a potential radius. So we don't know what, I'll call this r for lack of better words. So we have to find the length of r. But since we have a right triangle, we can use Pythagorean theorem for that. So if you want, take about 30 seconds to solve this. And instead of c, we'll call it r. Hopefully you recall that this is a Pythagorean triple, so you should be able to find r relatively quickly. If not, it's okay, or I'll give you time to calculate that. So hopefully you use the calculator, right? I sent you a link for a TI or a free TI-84. Hopefully you took advantage of that. I think it's 6 months of free calculator, and the software is very powerful, very powerful. So hopefully you took advantage. You downloaded it to your laptop, your computer. I don't know if you can download it to your phone. That I don't think you can do. So, if solved correctly, you have r as 17. 8, 15, 17 right triangles. It's a Pythagorean triple. So I'm going to redraw the triangle. Actually here, I'll highlight it for you. So now it should be on the slide. So now what you can do is you can easily figure out what sine. So here, what you need to figure out now is, let's start with the 3. Sine, really? So we need sine, cosine, and tangent. But if you have this triangle, I'll redraw it here. Don't forget, with respect to this angle, here's theta, 8, 15, 17. Again, label opposite, hypotenuse, and adjacent. And if we apply SOHCAHTOA, my board is acting up, sorry. If you apply SOHCAHTOA, you'll be able to find these ratios pretty quickly. So if we do that, so I'll write this over here. It's to the right now of the triangle. So sine theta, if done correctly, right, opposite to hypotenuse. Cosine theta, if done correctly, adjacent to hypotenuse. And then lastly, tan theta, which is opposite compared to adjacent. So hopefully you found that. But I'm going to give you about 30 seconds to find the reciprocal or the co-functions of each of these trig functions. So the vocabulary first, right? The reciprocal of sine theta, 1 divided by sine theta, but we call that cosecant theta. The reciprocal of cosine theta is secant theta. The reciprocal of tan theta, cotangent theta. And I want you to take a moment to find these trig ratios. And it should take you seconds, because it's really that simple. Okay, so if done correctly, you should have the following. So the answers are displayed there. Okay, so with that taken care of, let's see. So if we move along to the next part, this is where it gets a little bit complicated, right? So now I'm going to move along. Hopefully now you're awake. And now we can look at a little bit more complicated question. So now it says the terminal side of theta in standard position, passes through the point -3, -4. So that's going to place us, don't forget, right? Quadrant 1, 2, 3, and 4. So things to consider. The location of the quadrant. The point here, -3, -4, terminal side. So here, this is the ray, you can say. So we have a pretty large angle if we consider all of that, right? So, but what we can do, right, is we can still use this information here to create a right triangle. So here we have some length. Sorry for that. We have our side lengths here. And I will exaggerate the terminal side as black. So here what we have is the following. So if we look, what we need to do first is figure out the length of this terminal side. But if this is -3, -4, so this again represents x and y. Here's our length of x, which is -3. Y is -4. I think you know what the value of, I'll call it r, of what the hypotenuse is. So again, in positive world, this would be a 3, 4, 5 right triangle. But the same will apply here because when you square the negative, it becomes positive. So in other words, -3 squared plus -4 squared ultimately will be equal to +5 squared. So r is 5, or this missing side. But what we need to do is this. So with respect here now, so this is where it gets a little bit tricky. I want you to take a moment to find. I want you to find sine theta. So I'll write this over here. So now I'm to the left of the graph. Oh. So let's find sine theta, cosine theta, and tan. I'm sorry, this board, wow. This board is acting up. I probably have to restart my computer, but I'll do that after this class. So please be patient as I deal with these tech issues. So cosine theta, and yeah. So if you're watching the whiteboard, it's really acting up. I'm sorry about that. So take a moment to find all of these. So again, r is 5. I'm going to erase r right now. I'm going to write 5. So I want you to find the value of all of these, but be careful with the sign. Be careful with the sign. It's going to be very important, and it's going to allow us to make greater conclusions here. So I'm going to give you like a minute to 2 minutes to find sine theta, cosine theta, tan theta, but then also find the reciprocal or the co-functions for sine, cosine, and tangent. So take a moment, pay attention to the signs. It's going to play a huge role. So again, pay attention to the sign. Again, the negative. Don't forget that. And if you're dividing a negative with a negative, it'll become positive. So just for time's sake, because I'm pretty sure that you can fill out sine theta. So again, a question that you may have is where's theta, right? So that's a question that you may have. And our theta is going to be over here by the origin. So if we look, we have the following. So again, if you have a question, please ask. So theta would have been here. This board today. Theta. That purple angle that I just drew in the figure, that would have been our theta. So all of these answers that I'm going to show you now, that are projected, it's coming. So they're based off of this angle placement. Good morning, Kyle. All right. So some conclusions from this. So think about it here. You're in quadrant 3, and look at sine. It's negative. You're in quadrant 3, look at cosine. Also negative. But now look at tangent. So tangent, when you're dividing a negative with a negative, it becomes positive. So sine and cosine are both negative, tangent is positive, but then look at the cofunctions, right? The cofunctions are also negative for cosecant and secant because, again, they're just based off of sine and cosine. But then cotangent will be positive. So a conclusion that we can make from here is the following. And that conclusion is that in quadrant 3, tan is positive. But if you remember from algebra 2, I'm going to draw this on the board. You probably remember something like this. A, S, T, C, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you're looking at your board. And don't forget the acronym. All students take calculus. You remember that? All students take calculus. So just a way for you to remember the signs of these trig ratios when you're working on the coordinate plane, or depending on where the terminal side ends. So the fact that the terminal side ended in quadrant 3, tan is going to be positive. If the terminal side ends in quadrant 1, all of them, sine, cosine, tangent, and the reciprocal or the cofunctions are all going to be positive. And then sine and cosine, sine will be positive in quadrant 2, and cosine will be positive in quadrant 4. But we'll look at more examples that take all of that into consideration. Okay, so let's look at this next example, because this is where it's going to get complicated, and not to say that this question is more realistic, but it's more realistic that you're going to have this type of ratio. So when we look at example 3, so in looking here, we have to find, again, we're doing the same exact thing, but it's a little bit different now. It's saying that the terminal side of theta is defined by x plus 2y equals to 0. So it's a little bit different. So here, x plus 2y equals to 0. So if we do the following, right? Let's look. So we can graph it. We can graph that line. And what is it? X plus 2y? Oh. X plus 2y equals to 0. But remember, if we put it in y equals mx plus b form, which we could do, this becomes the following. So I'll draw this here. 2y is equal to what? Negative x. If we divide by 2, we have y is equal to negative 1/2 x. So our y-intercept is 0, so that puts us at the origin. And we would have to, or to find the next points, we would use the slope-intercept method, right? It's a lot of work. So just to save time, we could let x equal to 2. So if we let x equal 2, then we have y is equal to negative half times 2, or y in this case will equal to negative 1. So now look at what we have. So we have x equals 2, y equals 1. So in other words, the terminal side is in quadrant 4 for this particular question. So the point 2, 1 Here, it's somewhere here, again an approximation. So it'll look something like this. Oops, slightly off. So poorly drawn, and I'm sorry for that. So 2, -1, right? But then we have this angle essentially, right? But what we can do, so again, we can extend this. I'm going to exaggerate this. It's so poorly drawn, but again, it's just so that we can use or make a reference to this. So we're going to call this side length x and y. But we know this is 2 and this is -1. Do you need me to slow down? I feel like I could be kind of rushing. So I'm going to take a moment to pause. Any questions before I move forward? All right, so good. I'm glad. So let's do this then. I'm just going to redraw this. It got a little bit messy, so I went down. Just redrawing this, so we have something like this. Oh, this is so poorly drawn too. Let me just correct this. You can zoom in. So this is 2, -1. So I'll call this r. So again, we have to solve for the hypotenuse. So again, the terminal angle, or theta, excuse me, is going to be here. And we need to solve for r. So we do 2 squared plus -1 squared. That'll equal to r squared. But hopefully in solving this, you realize that this was 5 equals r squared, but r is really radical 5. So you have all of the components. I'm going to redraw the triangle underneath so you see it properly. So you really have something like this. This would be a length of 2, -1, and radical 5. And if theta is here, you have to find sine. Theta, cosine theta, tan theta. But not just these three, you also have to find the reciprocal identity. So again, once you find that, it should be pretty simple, but I warn you. So once you find all of this, if you have the radical, you have a radical in the denominator, it has to go away. You cannot keep an irrational number in the denominator. It must be simplified. Very tempting to do the following, to say that sine theta is -1 divided by radical 5. Very tempting to leave it like that, but what you really then need to do is you have to rationalize that denominator. So the refresher, to rationalize, you multiply both the numerator and the denominator by radical 5. So essentially you're left with negative radical 5 divided by 5. That is sine theta. So just another word of caution. So if you try to take the reciprocal of negative radical 5 divided by 5, then you're left with an irrational number again in the denominator. So this is good for sine theta, but I'm going to highlight this here. So I'm circling this in yellow, -1 radical 5, because if you take immediately, if you take cosecant right away, you have your answer, negative radical 5. It's simplified. So you save time. Negative radical 5 divided by 1. So you have to, be careful, right? Don't do, double work if you don't need to. And then also just make sure that if you do have that irrational number in the denominator, that radical, you have to rationalize the denominator. So in other words, you'd have something like this. So if everything is done correctly, you would have the following. So we took care of sine theta. And then immediately we took care of cosecant theta. But then cosine theta would take the same approach. You have the radical, again the denominator, but you need to rationalize that. And if done correctly, you'd have 2 radical 5 divided by 5. So I'll let you process this for a second, and then think about the cofunctions. But then another thing that you need to think about also is the value of sine, cosine, and tangent in these quadrants. So again, in this case, since we're in quadrant 4, I believe then what all students take calculus, right? Cosine. And if you look at cosine and its cofunction, so let's look at cosine theta, it's positive. Let's look at secant theta. It's also positive. So again, in the 4th quadrant, cosine is positive and the rest are negative, as you can see here. So now the issue arises. So I'm going to look at something very quick. I'm not going to spend too much time, and I'm just going to go right to the slide. So if we look at example 4, what if your terminal side is on an axis, or it ends up becoming a quadrantal angle? So again, let's say the terminal side is 0, 1. Right? So in other words, now we're looking at a 90-degree angle. Right? So what is sine of 90 degrees? What is cosine of 90 degrees? Tangent of 90 degrees. So something to think about here. So if the terminal side passes through 0, 1, right? So x is 0, y is 1, and then this r is 1. It's kind of abstract to think about. So it's a little confusing. It is, because you're used to something like this. So I'll just sketch it out quickly. So if we're here, so I'm graphing. So used to theta being here as an example and being a cube if the terminal side is in quadrant 1. But now imagine now this brown side length now becoming this blue side length here. So I'm continuing the angle, right? So I'm continuing the direction of the angle, so theta is no longer a cube. So now the brown becomes the blue, and this here is 90 degrees. So it's almost as if you have some vertical length and no horizontal length, right? So that's why x is 0. But if y is 1 and r is 1, so you potentially have something like this. It's going to be crazy, but just so that you understand here, you don't have a horizontal length. Your hypotenuse and your opposite side are the same length. So if this is theta, this is very abstract. It's just used to reference why these values exist, or what's presented below the graph here in example 4, why this makes sense. So if your opposite side and your hypotenuse are the same, sine 90 is 1. But if you look at the adjacent side, there's no adjacent side. It's 0. Right? So 0 divided by 1 is just 0, or cosine 90. But then here's where it gets confusing. So tan, right? Opposite divided by the adjacent. We'll have tan is undefined. And then you have the reciprocal functions, or the cofunctions, excuse me. So cosecant is 1, secant of 90 is undefined, and then cotangent becomes 0. So if I jump here to this slide, it kind of gives you all of the angles here, the quadrantal angles. And again, those go by increments of 90. 90, 180, 270, and 360. So they give you here in this chart the value of sine theta, depending on what theta is. So we looked at all instances of 90 degrees. But they change, as you move along the coordinate plane, or as you go up by increments of 90 degrees. So clearly 0 and 360 should be identical. And there's also some matching to some degree with 90 and 270. Certain things align, and you can see that in the chart. So I think here is a good place to stop. So I think for, let's see, yeah, for our purposes, I would rather you work on the try on your own. Actually, maybe some of you already moved on to that. So if you did, that's fine. But what I want to do, I want to give you the homework. So I want the homework to be this handout that I have assigned. Because we're basically done right now. So the homework, I'm sorry, my computer's running a little bit slow. If you go to the classwork section, let's see here. Where is it? I think it just says trigonometric functions, right? So there's a handout that just says trigonometric functions, and if you're looking at it, it's very similar to what we just did. So from that handout, I want you to work on question 7 for 59. Oh, hold on, I'm going to write it here. Because it's not rotated properly, so 4, 7. So for homework from that handout, 4, 7, and 54, 56, 58, 59. 54, 6, 58, 59. So here's the homework. And I'll post this in our classwork or the homework section. Okay. So that's the homework for tonight, the handout. It should be entitled Trigonometric Functions. It says work on circled questions, but you're going to work on only those circled questions. Oh, and 24. Sorry. And 24. I just noticed that now. So I'll make that clarification. I'll share it with you guys. I'll put it in the actual homework section for this handout, and I'll include it also in the stream if necessary. Any questions for me before we part today? Any questions for me? So as you think of a potential question, again, your exam, it was graded, everything was shared with you, and that's on Jupyter. I have to add the homework grade still in Jupyter from whatever you did within Google Classroom. So just be patient with that. I think your grades are due tomorrow. I have to follow up. It's kind of hard. I'm like, like I said, like I mentioned this every now and then, like I'm still working at Academy, but kind of not. It's like very bizarre, but again, I'm just very happy to still be affiliated with Academy. Remember, my home for the past 11 years, but I believe grades are due tomorrow. I'll stand corrected, but you'll have all of that updated before you get your report card. But if you look at your grade now in Jupyter, it should be pretty close to what you'll be getting for this current marking period. So I'm just giving you a heads up. Any questions for me before we part? Last minute thoughts, comments, concerns? It's also Teachers Appreciation Week. I'm not saying that I'm looking for you to gas me up to say, you're a great teacher or anything like that, but maybe a little bit later today you can, if you see your teachers, it probably would be nice if you said, Happy Teacher Appreciation Week. Especially, considering everything that's going on, it's, really tough for a lot of teachers. We also understand it's really tough for students, but, if you see Mr. or Miss So-and-so later on in the day, wish them a Happy Teacher Appreciation Week. I'm pretty sure they'll be thankful for that, and I just wanted to share that with you. And on that note, have a great day. I'll see you tomorrow, and to be continued. See you later.